Hello everyone, welcome to my presentation. My name is Rezazadegan. I am Ph.D. candidate in Chair of Constructive Design at Bauhaus University, Weimar, Germany. I graduated in Master of Science in Media Architecture at the same university. I accomplished my bachelor degree in architecture in my home country, Iran. The topic of my Ph.D. research is how architectural green planted modules can play a role as a controller against air pollution in megacities. The purpose of this research is to propose a solution to the air pollution issue in megacities, which is caused by urbanization and overcrowded population through the use of architecture. Urbanization leads to air pollution because of the lack of greenery and the multiplicity of pollutants. When there is more air pollution, it warms the earth. Drought and heat will destroy plants that have so far survived. As the cycle will repeat itself, now is the time to find solutions in different aspects of society to stop and decrease its harmful effects. According to IPCC, the Intergovernmental Panel on Climate Change 2007, when CO2 is released into the atmosphere, over 50% will take 30 years to disappear, 30% will remain for several centuries, and 20% will last for several million years. These facts cause CO2 to be regulated as a pollutant. In terms of air pollution, cities are one of the most significant areas to consider because they are always influenced by not only high level of air pollution from traffic and industry, but also the demands of new migrants for new constructions, which release pollutants and destroy natural areas, which in turn also creates more air pollution. Nature has the capability to balance itself. Regarding air pollution, plants' photosynthesis is proof of this fact. This research takes the potential of plants in absorbing CO2 in architecture to help cities counteract the harmful effects of urbanization. But it is important to mention that due to destruction of green areas via construction and the resulting global warming phenomenon, this delicate act has been thrown out of balance. What if architecture were to help this act as a mediator to balance it again? While green walls appear to be one possible solution to the problem of air pollution, it must be stated that green walls are not sufficient by themselves. Many architects and building owners are not willing to cover facades with plants because it reduces the variety and creativity in built areas design and as they might have harmful effects on their environment regarding dirt, insects, allergies, etc. Besides, green walls need a long period to be able to cover the wall and afterward start acting efficiently. Furthermore, most of the current green walls lose their leaves in fall and winter, and they transfer to a dried wood branch. Regarding CO2 absorption, each leaf acts as a catalyst. The lack of leaves means there will be a few amounts of CO2 absorption. This research proposes a modular green wall system that is pre-constructed. When it attaches to the facades, it starts to act functionally regarding air purifying from the initial moments. It does not need much time to reach its highest efficiency on the facade because it is already grown in greenhouses. This research shall consider all aspects of existing green walls, evaluate the advantages and disadvantages as the initial studies for proposing a better version of them with the main focus of conflicting with air pollution issues. In this regard, I will investigate the amount of CO2 absorption through case studies of green walls using different kinds of plants and considering the efficiency. It is important to document current existing air pollution indices for use as an input and output more accurate statistical models. The second goal is to improve upon green walls by transforming the concept into a model by proposing three specific plants with high efficiency in CO2 absorption and introducing new methods of using them to improve their air purification capabilities. An additional goal is to increase architects' and owners' enthusiasm of using this module on the facade of buildings. To achieve this, I need to use existing data and find out how it is possible to build a biotechnical module which has an appropriate CO2 absorption capacity when compared to energy and cost requirements, which waste it produces, and a design that conforms to different wall shapes and acts as a module. I would like to introduce my master thesis project as one initial answer to my current research. The product as the result of this project is called a smart plant stand. The smart plant stand is a horizontal hexagonal box of which the four side panels forming the hexagon and half of the front panel are made from transparent solar cell. The top side is open for the plant to grow. The bottom side is where the pot is located. The bottom side is made from aluminum. There is a white PVC plate which divides the plant space from its back, which is a place to locate electronics. The plant stand hangs from the aluminum backside to the facade of built areas in groups of as many as possible to help purify the air. Each smart plant stand module possesses an Arduino Uno, which is a microcontroller, LED grow light, and water pumps. There are light sensors and moisture sensors which analyze if the plant needs more lights and water, respectively. The plant stand consists of new technology and materials that make planting easy for everyone. The IoT technology makes the watering and lighting of the plants completely without interference of human, and the transparent solar cell, which is very new material in solar material worlds, help the plant stand to be sustainable and clean. The project is designed modular. Modularity is against complexity. Modularity is the degree to which a system's components may be separated and recombined, often with the benefits of flexibility and variety in use. The module could be attached together and create a new form. Besides, shape, texture, angles, materials, and color are important factors in modularity. This project chooses to be modular because it is what will attach to facade of old or new buildings, as many as the owners want. If someone wants to hang just one module on the facade, this modular plant stand in transferring the product ideas and aims is as complete as when someone wants to use more than one module. Just like molecules, each module has the whole features of the product. After hanging the modules on the facade of building, tiny water pipes come among the modules to provide the demanded water by the plants. It is notable that each module has a hole at the bottom side to bring out the extra water of the soil and also to expel raining water. The plants which are chosen for this project are rich in absorbing CO2 based on NASA investigations. They are Japanese maple and jade plant, which have red and green leaves, respectively. Using a combination of the plants could help increase the potential benefits. In the result, the smart plant stand not only affects on aesthetic aspects of cities and make them greener, but also it has functional contribution with the environment, and it helps built areas to be as a medium regarding air pollution, which acts well as a new identity in cities. Thank you for your considerations.